Okay, we're going to do 6.2 problem exercise number 1. And on that, we're supposed to find the region bounded by y equals e to the x by x equal minus 2, x equal minus 1, and the x-axis, and revolved around the x-axis. So I'm going to try to draw it carefully here. So if that's minus 2 and that's 1, e to the minus 2 is 1 over e, which is small, like a ninth or something like that, and it goes something like this. So that's the y equal e to the x. Here's x equal minus 2, x equal minus 1. So we get this region revolved around the x-axis, which should make it come down here as it comes around and goes back through the plane. So it's circling like this. And almost like the leg of a sofa or something like that. And it's round. And so if we're going to do this one, probably the easiest to do is the disk method. Which means we're going to slice it perpendicular to the axis. And the axis was this line, so perpendicular to it would be this way. And so a slice would make a circle, a disk, a circle with some thickness, a disk with some thickness. The thickness would be this way in the x direction, so its thickness we're going to call dx. And we're going to integrate from, let's see, it's going to be dx, and the x's are going to go from minus 2 to minus 1. And it'll be pi large radius squared. There is no hole in it, so I don't need to do the minus to the little r squared, so it's pi r squared. Now we just have to get the radius in terms of x. Now any point on this curve is going to be over x and up y, over x up y, and that gets us to a point on the curve x, y. So this direction's y and this is x. So y is the height, but we need it in terms of x. But y is e to the x, so it's going to be pi antiderivative minus 2 to minus 1 of e to the x, that's the radius, squared dx. So if I just do the part inside the parentheses, I get e to the x squared. Second, calculate the integral from minus 2 to minus 1. Negative 2, enter, negative 1, enter, and I get pi times 0.0585909, which is like 1 rounded off. So I'm going to take that answer. Oh, and I just did it here. And that comes out to be 0.1838-ish. Okay? So I didn't bother trying to find the antiderivative of e to the x squared. Let's see, what would that be? That would be pi integral of, that's e to the 2x. So if I integrate e to the 2x, it's going to be e to the 2x divided by 2, because if I take the derivative of e to the 2x, it's e to the 2x times the derivative of that, which is a 2, which cancels the half. So that would be it, evaluated from -2 to -1, which would be pi over 2 e to the -4, e to the -2 minus e to the -4, which is pi over 2, 1 over e squared minus 1 over e to the 4th. So there's the exact answer, and there's the decimal approximation. Okay.